will do now by using without voltage division rule. Okay, diagram would be same. Now this is for the non-inverting amplifier. As you know, if it is non-inverting amplifier, the voltage supply would be connected to positive or negative. Tell me that. Tell me. If there is a non-inverting amplifier, so we'll connect the voltage to the positive terminal or the negative terminal. Voltage will be connected to the positive terminal. So can I connect the positive here like V in, right? Another terminal would be grounded. Okay, another terminal is, this is V output, for that is denoted by V naught, right? In this also we'll take a feedback resistance, but from the downward side, right? In the inverting terminal we connect the feedback resistance from the positive side, but this is in this we'll take the inverting feedback resistance from the negative side, that is denoted by RF. Okay, now we have to connect R1 also between the terminal and the feedback, right? That is R1, and another term would be grounded. So let us consider, in this current I2 is flowing and in this current I1 is flowing. Okay, so here the voltage we can consider it is V positive, or we can consider it is V negative. So from the virtual ground concept, can we write down directly V positive is equal to V negative? You can mention it that it is the concept of virtual ground. You just need to write down the in the bracket virtual ground concept. Okay, so V positive is equal to V negative, right? So can we say that, as you can see that there is no resistance between these two terminals, so can we say that V in is equal to V positive? Hmm? There is no resistance, no element, so we can, so no impedance. So if it is V in will give 2 volt, then V volt also 2 volt, and V negative also 2 volt. So all are the voltages are equal, right? Any doubt up to here? So we can say that this one is, can we say that like this, I1 must be equal to I2, because as you can see that there is a current flowing over here, and no current will flow over there, the current would be growing through the grounded, okay, through the resistance one, R1. I1 is equal to I2, and as you know the nodal analysis, I1 is how much? V by R, right? So what is the voltage over here? That is V negative. So this R1, this I1 is going from V negative to the grounded, right? I1 is moving from V negative to the grounded. So can we write down V negative minus 0 divided by R1? Can we write down like this? Hmm? See, I told you na, nodal analysis. Nodal analysis, I1 is the current flowing from which node to which node. It is moving from V negative to 0. So it would be V negative. You can write it down like this. V negative minus 0. Okay. And now tell me, I2 is moving from which node to which node? I2 is moving from this path. So it would be, so it starts from V naught. It starts from, yeah, it is V naught. V naught is the output voltage. So it starts from V naught and it ends to V negative, divided by how much resistance? RF, right? Okay, now tell me, any doubt up to here? V negative can we write down as V in? So it would be V in minus 0 divided by R1, again V naught. Again, can we write down V negative as V in? So it would be V naught minus V negative is V in divided by RF. Okay. So as you know, there is a relationship between what we need to calculate. We need to calculate V naught by V. V naught by V in. If we'll solve it, then what would be the value? You will get, that is C V in by R1, and that is V naught minus V in divided by RF. So you can cross multiply the things, then you can take V in common. So after solving it, you will get the final term as 1 plus RF divided by R1. This is our final answer for V naught by V. Got it? So for the inverting amplifier, what is the gain? That is minus RF by R1. It is voltage gain, that is denoted by AV. Okay.